On April 26, 1986, part of the core of Unit 4 melted and turned into lava, along with sand dumped there in an attempt to extinguish the fire. It spread into the basement rooms and solidified. This melted 170 tons of radioactive uranium. Neutrons began to appear and accumulate in several places already. 35 years have passed since the explosion at the Chernobyl nuclear power plant, which led to the worst nuclear accident. Now fission reactions are starting again in the mass of uranium fuel buried deep in the mangled reactor hull there. It's like smoldering embers in a brazier, says a chemist, Neil Hyatt, who studies nuclear materials at the University of Sheffield. Ukrainian scientists were urgently trying to determine whether these reactions would subside on their own or whether emergency interventions would be needed to prevent another accident. Sensors recorded an increase in the number of neutrons escaping from one inaccessible room, indicating a fission reaction. Anatoly Doroshenko of the Kiev-based Institute for Nuclear Power Plant Safety Problems, or IPB-NPP for short, said this during a discussion about dismantling the reactor. There are many uncertainties, but we cannot rule out the possibility of an accident. The number of neutrons is slowly increasing, indicating that those in charge of managing the situation still have a few years to find ways to deal with the threat. Any ways to prevent an accident would raise a lot of interest in Japan, which itself has to deal with the aftermath of the nuclear disaster that happened 10 years ago in Fukushima. The risk parameters there are similar, Hyatt notes. The premonition of a fission chain reaction in nuclear ruins has long haunted Chernobyl. When part of the core of Unit 4 melted on April 26, 1986, uranium fuel rods, their zirconium cladding, graphite control rods and sand dumped on the core in an attempt to put out the fire turned to lava. The lava spread into the basement of the reactor hull and then solidified to form a core melt. It contained about 170 tons of radioactive uranium, that is 95% of the total fuel. A year after the accident, a sarcophagus of steel and concrete was built over the remains of Unit 4, dubbed the shelter. Through it, water was allowed to enter. Because water slows down neutrons, which increases the chances of uranium nuclei fission, the number of neutrons sometimes increased dramatically due to heavy rains. After heavy rains in June 1990, a Chernobyl stalker scientist, despite the threat of radiation exposure, went into the damaged reactor hull and sprinkled a solution of gadolinium nitrate, which absorbs neutrons, onto the fuel-containing materials there. This was done because the melt could reach a critical mass, which was feared by the specialists. A few years later, sprinklers for gadolinium nitrate were installed on the roof of the shelter. But it cannot penetrate into some basement rooms, so the effect is small. Chernobyl NPP management believed that the risk of criticality would be reduced with the installation of the new safe confinement, NSC, above the shelter in November 2016. This €1.5 billion structure was supposed to isolate the shelter in a way that would stabilize it and eventually dismantle it. The NSC also keeps the rain out, so that with its installation the number of neutrons in most points of the shelter remains stable or even decreases. But neutrons have begun to gradually appear and accumulate in several new locations. In 4 years, their number has almost doubled in room 305/2, where there is a ton of melt under the rubble. A model prepared by the Institute for Nuclear Power Plant Safety Problems indicates that frozen fuel causes neutrons passing through it to fission uranium nuclei more efficiently. This is valid and convincing data, Hyatt says. We just don't understand what the mechanism is. This threat cannot be ignored. As water levels decline, there are concerns that the fission reaction will accelerate progressively, Hyatt notes. And that will lead to an uncontrolled release of nuclear energy. There is no chance of a repeat of the 1986 tragedy, when an explosion and fire generated a radioactive cloud that washed over Europe. The uncontrolled fission reaction and the melt could die down after the remaining water vaporizes due to the high temperature of the fission. But Savelyev notes that while the explosive reaction could be contained, it threatens to collapse the unstable elements of the rickety shelter, at which point the new safe confinement would fill with radioactive dust. Solving this new problem will be extremely difficult. The high radiation levels in room 305/2 preclude the installation of sensors there. Sprinkling gadolinium nitrate is not an option either, since the melt is under the concrete. There is an idea to create a robot capable of withstanding prolonged irradiation to drill holes in the melt and insert cylinders with boron into them, which will act as control rods and absorb neutrons. Meanwhile, the Institute for Nuclear Power Plant Safety Issues intends to intensify surveillance of the other two sites where the melt could reach a critical state. Renewed fission reactions are not the only problem facing Chernobyl keepers. Under the influence of powerful radiation and high humidity, the melt decays, generating even more radioactive dust, which impedes plans to dismantle the shelter. At first, the radioactive formation from the lava called Elephant's Leg was so hard that scientists had to fire a Kalashnikov rifle to break off a piece for analysis. Now the leg is more or less like sand in its consistency, Savliev says. Ukraine has long wanted to remove the meltdown and send it to a repository for radioactive waste in stable geological formations. With the help of the European Bank for Reconstruction and Development, it intends to prepare a comprehensive plan for such work. But since the restless remains of the reactor are still lukewarm in the shelter, it will be exceptionally difficult to bury them. Subscribe to the channel and share this video with your friends. Give it a thumbs up. Tell us interesting facts you know about the topic of this video. See you in new videos.